You know that magic box sitting in your kitchen? The one that can take a frozen brick of food and turn it into a hot meal in just a few minutes? Well, how does it actually do that? Today, we're going to pull back the curtain on the microwave oven and uncover the seriously surprising and brilliant science that makes it all work. All right, let's kick things off with a little true or false quiz that gets right to the heart of what most of us think is happening. We've all heard this one, right? That microwaves use some kind of magic frequency that's perfectly tuned to water, making it vibrate like crazy. So what do you think? Is that true?
If you said false, you are absolutely correct. The answer is a big, fat no. Honestly, the idea that microwaves use a special resonance frequency is probably the single biggest misunderstanding about this appliance. And the real science? Well, it's way more interesting.
So, if it's not resonance, then what in the world is going on inside that box? Let's bust this myth once and for all and take a look at the real physics that heats up your leftovers. Okay, the correct scientific term for this is dielectric heating. Now, I know that sounds a little complicated, but the idea behind it is actually pretty simple. Microwaves create this electric field that makes certain molecules in your food, especially water, flip back and forth really, really fast. All that flipping creates friction, and that friction creates heat. Let's break this down. Just imagine that every single water molecule in your food is a teeny tiny magnet. The microwave creates an electric field that switches its positive and negative poles about 2.45 times billion times a second. Can you even picture that? So the poor little water molecules are just desperately trying to keep up, twisting and turning to align themselves. All of that frantic motion creates a ton of friction, and it's that friction that actually cooks your food. Okay, so this brings up a huge question, right? If it's not some magic resonance frequency, then why do all microwave ovens use exactly 2.45 gigahertz? Is there something special about that number after all? I love this quote because it sums it up perfectly. 2.45 gigahertz isn't magic, it's a compromise. It's the Goldilocks frequency, not too hot, not too cold, but just right to balance a bunch of different factors to make the whole thing work. And that compromise really comes down to three main things. First, you've got physics. At 2.45 gigahertz, the waves can penetrate a few centimeters into your food, which is perfect. Any higher, they just scorch the surface. Any lower, and they'd go right through it. Second, regulations. This frequency is part of a global unlicensed radio band, so companies don't have to pay for expensive licenses. And third, good old-fashioned engineering. It just so happens that the Magnetron, the part that actually makes the microwaves, is cheapest to build for this exact range. Now, that unlicensed band is a pretty busy place. Your Wi-Fi router, your Bluetooth headphones, a lot of your gadgets operate right around 2.4 gigahertz. And this, of course, leads to a very common question. If a microwave can cook a potato at that frequency, what is my Wi-Fi router doing to me? Well, the answer comes down to one simple thing: power. Just look at this chart. A typical microwave is blasting your food with about 1,000 watts of power. Your Wi-Fi router, it's putting out maybe 1 watt. It's the difference between a fire hose and a slow drip. Same frequency, sure, but a totally different league when it comes to intensity. And here's another really crucial point. You have to understand the type of radiation. Microwaves are non-ionizing. That means they've got enough energy to wiggle molecules and create heat, but they don't have anywhere near enough juice to break chemical bonds or damage your DNA. That's the job of dangerous ionizing radiation, stuff like X-rays. In fact, believe it or not, the visible light you're seeing right now is actually more powerful than the microwaves from your oven. Okay, let's switch gears and talk about a problem that every single one of us has faced. You know the drill. You heat up your leftovers, and one bite is like molten lava, while the spot right next to it is still ice cold. So why does that happen? And what have engineers done to fix it? The culprit here is something called standing waves. As the microwaves are bouncing all around that metal box, they start to overlap and interfere with each other. This creates a fixed pattern of peaks with super high energy, those are your hot spots, and valleys with almost no energy at all, your cold spots. So how do we fight back? Well, the classic solution is the turntable, which just physically moves the food through that energy pattern. And hey, here's a pro tip for you. Put your food on the edge of the plate, not the center. That way it actually travels around the oven instead of just spinning in place. Some ovens also have a hidden fan to stir up the waves. But the most high-tech solution is a totally different kind of technology. You see, when you set a conventional microwave to, say, 50% power, it's kind of lying to you. What it's really doing is blasting at 100% power for half the time and then turning off for the other half. It just cycles on and off.
That's what gives you those rubbery edges. Inverter technology, on the other hand, is the real deal. It delivers a true, continuous stream of lower power, which cooks your food way more gently and evenly. Now, with all this power being blasted inside that oven, how do we stay safe on the outside? Let's take a look at one of the most brilliant but totally overlooked pieces of engineering in your entire kitchen, the microwave door. The first line of defense is the one you can see. That metal mesh on the window? Well, the wavelength of the microwaves is about 12 centimeters long. The holes in that mesh are just a couple of millimeters wide. The waves are literally too big to fit through the holes, so they just bounce right back into the oven. It's that simple. But there's a second, invisible shield that's even more clever. Built right into the edge of the door is something called a choke structure. It's basically a very precisely engineered metal channel that acts like a maze or a trap for any stray microwaves that try to sneak out around the door seal.
And this is where it gets just mind-blowingly cool. This is right from the actual patent. The engineers designed that little channel to be exactly 1/4 of the microwave's wavelength. Because of the physics at play, at that specific length, the channel creates what's called infinite impedance. In simple terms, it's a perfect wall. It's a dead end that is perfectly tuned to stop that one specific type of wave.
So what this all means is that the door's safety isn't just about a good seal. It is quite literally an invisible force field that's created by pure geometry and physics, engineered right into the shape of the metal itself. It's just an incredibly elegant piece of engineering. The whole history of this technology is fascinating. The magnetron, the heart of the oven, wasn't invented to heat up your popcorn. It was developed and perfected during World War II for radar systems to detect enemy aircraft. After the war, this battlefield tech was repurposed, and by 1967, it had found a brand new home right in our kitchens. So, from top-secret military radar to kitchen convenience, the microwave oven is an absolute marvel of physics and engineering. And it really makes you wonder, what other extraordinary secrets are hiding inside the everyday objects we use without even a second thought? Thanks for being curious with me.